Now we look at our next method, and we're dealing with what's called exact equations. So the idea, again, is that it comes from df equal to 0. So we want to have the total differential of some function on one side and 0 on the other side, so we can integrate, because the integral of df is f and the integral of 0 is c. So I've got two examples. My first one is here, x cubed plus y cubed dx plus 3xy squared dy. So I have it in the form of m dx plus n dy. So this is my m, x cubed plus y cubed, and this is my n, 3xy squared. So let's see if it's exact, and we can use this method. Well, we take the partial of m with respect to y, so that would be 3y squared. Now I take the partial of n with respect to x, so again, that's 3y squared, so therefore this is exact. Now, it does not matter which one I choose, the m or the n. I'm going to choose the m, so I'm going to integrate x cubed plus y cubed with respect to x. So I will get x to the 4th over 4 plus x times y cubed plus, now usually we write a plus c. But because I'm integrating with respect to x, and this is a function of x and y, my plus c will be a function of y, because y was held as a constant. So y is a constant relative to x. So this is f. df equals 0. This is the f. Now, let's take the partial of f with respect to y. So I'm going to take the partial of this with respect to y. So x is a constant relative to y, so the partial with respect to y of that would be 0 plus 3xy squared plus, this is a full function of y, so therefore I'm going to have c prime of y. But since this is exact, and this left-hand side, or this one side of the equals, is the total differential of f, n is the partial of f with respect to y. M is the partial of f with respect to x. So n, so I can set this equal, since it's the partial of f with respect to y, I can set it equal to 3 times x times y squared. So we notice the 3x, y squareds cancel out. So therefore, c prime of y equals 0. So c of y, integrate both sides, equals c. So I have what c of y is. So my f is x to the 4th over 4 plus xy cubed, and then equal to, I got a c here, but again, what's the integral of 0? It's c. So there is my final answer. It's x to the 4th over 4 plus x times y cubed equal to c. Now let's look at this next example. So again, I have it in the form of m and n. M in this case is 1 minus 3 over x plus y, and n is 1 minus 3 over y plus x. So again, I want to check to make sure it's exact, that it's of this form, df equal to 0. So let's take the partial of m with respect to y. Partial of m with respect to y in this case is 1, because that's all I've got in front of the y. Let's take the partial of n with respect to x. Again, it's 1. So therefore, this is exact, which means this is the partial of f with respect to x. This is the partial of f with respect to y. Now, if you don't mind, this time I'm going to choose n and integrate the partial of f with respect to y with respect to y. That way I get f. So f equals the integral of 1 minus 3 over y plus x dy. So I'm integrating with respect to y. I'm using calc 3. So therefore this would become y minus 3 ln of absolute value of y plus x times y plus, again, a plus c, but the c this time is a function of x. So that's my f. So now let's take the partial of f with respect to x. The partial of f with respect to x, these all have y's in them, so they're constants, so the derivative of a constant is 0. So I would get plus y plus c prime of x. Well, what else do I know the partial of f with respect to x is? Well, it's m. So let's set that equal to m. 1 minus 3 over x plus y. The y's cancel out. So I get c prime of x equals 1 minus 3 over x. So what do I do to get rid of a derivative? I integrate. So integrate c prime of x gives me c of x, and this would be integrating 1 minus 3 over x dx. So of course I get x minus 3 plus the natural log of absolute value of x. So x minus 3 times the natural log of the absolute value of x plus c, but I'm going to have a plus c on this side anyway. If you put it there, that's fine, but I'm going to have a plus c, and what's an arbitrary constant plus an arbitrary constant? An arbitrary constant. So let's plug this in to my f. So again, f is what? Y minus 3 ln absolute value of y plus x times y plus x. Now I'm replacing the c of x with this, minus 3 ln of x absolute value equal to c. Now this is my answer, and I would allow this answer, but the book oftentimes simplifies it, so let's put it together. So this would be x plus y plus x times y minus 3 times the natural log of the absolute value of x times y. That's using the properties of natural log. Natural log of a plus the natural log of b is the natural log of a times b. And then equal to c. So again, books oftentimes simplify it, and if you wanted to, you could put the two natural logs together. So the idea of this exact method is that on one side you have the total differential of some function, and on the other side you have 0. So you integrate both sides. Basically, that's what we're doing.